This problem is again about the conservation of energy. In this case, you have two types of energy. One is the translational energy and the other is rotational energy. So from the given gravitational potential energy, the energy is now changing into the translational energy plus the rotational energy. So you need to understand the concept of what is the kinetic energy in a translational motion, what is the kinetic energy in a rotational motion, what is the moment of inertia, what is the angular velocity. So you need to have all those backgrounds here. Okay, and let me explain this problem. And first, so in this case, you're given an inclined plane here, and then you have a ball or a sphere. This is a solid sphere. Solid sphere. You have a solid sphere here. Once you let this sphere roll down, oh no, this is the solid disk. This is my bad. This is a solid disk. This is not a sphere. This is a disk. So once you let this disk roll down along the inclined plane, and you know the radius, you know the mass, you know its angular velocity, then you need to find out what this height is. This is the height. Okay. So once you roll down along this inclined plane to this point, you need to find it out the height. Let's write down all the given information here. So the given information you have the radius of the ball, which is equal to 1.6 meter. Make sure that all the units are in SI system. This one is the mass is given as 2.3 kilogram. And the angular velocity, I'm not taking care of the significant figures for now. If we want to take a measurement, yes, of course you have to take the significant figures into account, but for now, it's okay. The angular velocity is denoted by omega, which is given 5.35 radian per second. Always remember, you have to express this into radian per second. And once you know what is the angular velocity, it gives you how fast it is moving about an axis. And once you know this angular velocity, you can calculate its linear velocity. So the linear velocity is the velocity at any point. The tangential velocity. So the velocity is given by r omega. We know the radius, which is 1.6, and times omega is 5.35. So use your calculator and then you will find it out. This velocity is 8.56. 8.56 meter per second. We got its linear velocity now. Okay? Or in other words, we can say that the linear velocity is the velocity of the center of the mass. So when certain thing is rolling down an inclined plane, it rolls as well as it moves. So it does have the two motions. One is the rolling motion and the other is the translation motion. So this velocity gives you the velocity of the center of mass. And now, so we are going to use the principle of conservation of energy. Before we move that, I would like you to point it out. This is a disk, and the moment of inertia of a disk is given by half m r squared. Okay, this is the moment of inertia of a disk. So now let's use the principle of conservation of energy. So the total energy at this point A has to be equal to the total energy at point B, but there is a difference. At point A, you have all the potential energy. At point B, you have the kinetic energy. So the potential energy at A has to be equal to total kinetic energy. Total kinetic energy at B. What is the potential energy? It's only the gravitational potential energy. So this is equal to mass times g times the height. And this one has the two types of energy. One is the translational energy and the other is the rotational energy, the total kinetic energy. Translational kinetic energy plus rotational kinetic energy. Rotational kinetic energy. So we know that the translational kinetic energy is equal to half m v squared. And as I say, this is the v here, or curly v. Once it starts rolling down, then, or I'll just put the v here. So once it rolls down, the center of mass moves with this velocity v. Okay, and the rotational kinetic energy is equal to plus half I omega square, and this is equal to mgh. So I'm writing down this side now. So the mgh equal to half m v squared. What is the I? I is half m r squared. As you can see from here, this is the moment of inertia, and the moment of inertia of a disk is half m r squared. So just writing down here, just to simplify, half m r squared and omega squared, This mass, and this mass cancels out. So you have g times h v squared over 2 plus half r times omega. We know that r times omega is equal to v. Oh, so I'm missing one half here, because this half I'm missing here. So I have one more half here. So this will be 1/4. And r times omega is the v. R times omega is v, so this will be v squared. V squared. So g times h, v squared 1/2. This is 4. 2 v squared plus v squared. This is 3 v squared over 4. So the h, the height, is equal to this. H is equal to 3 v squared over 4 times g. Plug in all the information. 3 What is V? V we already have calculated, which is 8.56. 8.56 square divided by 4 times G is 9.8. Once you put all the numbers, the height you'll get is 5.8